Here's an example of adding vectors in 2 dimensions graphically first, and then adding vectors in 2 dimensions mathematically. If you want to add vectors in 2 dimensions graphically, we're going to need ourselves an orientation. We're going to need ourselves a scale. For this scale, I've said that 10 centimeters on my whiteboard is 100 meters. You might put down on your piece of paper that 1 centimeter is equal to 100 meters. There's our orientation. That could be north, south, east, and west. It could be up, down, left, and right. It could be anything that you want. I'm going to be adding these 2 vectors over here, a displacement. S1, that displacement is going to be 400 meters to the east. S2 is going to be a displacement of 300 meters north. I'm going to add them graphically. Now, I've added these 2 vectors by going from tail to head, tail to head. What I need to do now to find the displacement, the sum of these 2 vectors, is to draw in a resultant vector from the tail of the first one to the head of the last one. So here's our resultant vector. We want to solve this graphically. We're going to measure the resultant vector using a ruler and then convert that using our scale. 50 centimeters means that we've got a 500 meter resultant vector using our scale. 50 centimeters, where 10 centimeters is equal to 100 meters, that's 500 meters for our resultant. Now we need to figure out the angle or the direction of this vector. If we've gone and been very careful about our orientation, our scale, if we've drawn in our vectors very carefully, then we can use a protractor to figure out the angle theta. I'm reading 37 degrees. And so we find our resultant vector to be 500 meters north, 53 degrees east. So how do we do this mathematically? For something like this, where we've given 2 displacements that are at right angles to each other, we can take advantage of something called Pythagoras' theorem. Recognizing that this is a right angle triangle, we can recognize that we have a hypotenuse and that the hypotenuse, the square of this hypotenuse, is equal to the sum of the square of the 2 other sides. And so we get together our displacement, the square of each of those, add those together, that's the square of our hypotenuse. We find that then our hypotenuse is equal to the square root of 250,000, which gives us an answer of the resultant vector being 500 meters. Exactly what we had graphically, provided that we were careful with our drawings. What about the angle theta? We know that tan theta is equal to the opposite over the adjacent. So let's work with that. If tan theta is equal to the opposite over the adjacent, then theta itself is equal to tan to the -1, 0.75. If you want to do that on your calculator, then you go Shift, tan, and then you type in 0.75, hit enter, and you'll get the answer, which is 37 degrees. And if this is 37 degrees, then that tells us the direction of our resultant vector is going to be north, 53 degrees east. So solving this problem graphically, if we're very careful with our drawing, we can get the correct answer. Solving it mathematically using Pythagoras' theorem and a bit of trig, we can also get the answer. I hope that was useful.